So, hello friends, we are back with IGCSE Physics topic 1.3 mass and weight, and I hope that you all enjoy and learn from it. So, let's move forward and complete this topic quickly as it is an interesting and easy one. So basically, what is mass? Mass is the measure of the quantity or the amount of matter which is present in an object at rest relative to the observer. So here, this line is quite important when you are describing it about in the exam as at rest relative to the observer, because there should be the object should be at rest. That is one of the main things, and mass is a measure of the quantity of matter or the amount of matter, the amount of substance which is present in an object at rest relative to the observer is the mass. So friends, this is about mass, and mass is a scalar quantity, which means that it only has the magnitude. It does not has the direction. It has the magnitude only. Well, the SI unit for mass is kilogram, that is kg. And uh, there's one thing. Whenever you check your weight, it's and you just tell that it's of 50 kgs or 75 kgs, let me tell you it's wrong. The SI unit for mass is kilogram. So your mass is 75 kgs, 80 kgs, 50 kgs, etc. But your weight is never measured in kgs. Weight is a force. We'll discuss about weight in detail in the upcoming slides. But before that, let's finish the topic mass. So consequently, mass is the property of an object that resists change in motion. The greater the mass of the greater the mass of the object, the more difficult it is to speed it up, slow it down, or change its direction. Now that is because of another concept which I'll be writing here, that is inertia. Inertia. And inertia is the tendency of an object to resist the state of motion or rest in which the object is already in. So inertia is nonetheless the state of the object, and this property is, friends, directly proportional to what do we say, it's directly proportional to mass. So mass and inertia are related together, and so higher the inertia of the object, higher the mass of the object, higher the ability to resist the state of inertia. So the always remember, greater the mass of the object, uh, it is more difficult to speed it up, slow it down, or change its direction. In general, more difficult to change its state of motion. Moving forward, a mass is quite a few times given in what do we say, in grams. So 1,000 grams is equals to 1 kg. So always remember, 1 kg is equals to 10 to the power what? 10 to the power minus 3. Always remember this thing. And moving forward, this is an easy topic, and I'm sure all of you must have learned this in mathematics previously, with that is conversion. So here are a few worked examples, and we'll just go through them. So an object has a mass of 2.7 kg. State the number of grams in 2.7 kg. So first, what do we do is that we write 1 kg is equal to how many grams, and then we convert it. So that is 2.7 kg into gram. That becomes 2.7 kg into 1,000. That is 2,700 grams. So this is all about grams. Moving further, we will now study weight in detail. So let's just revise what we have done till now. That's mass. Mass is a measure of the quantity of matter in an object at rest relative to the observer. It is a scalar quantity. The SI unit for mass is kilograms. Consequently, the property of an object that resists change in motion. As higher the mass of the object, the more difficult it is to change the motion of the object, change its direction, etc. And mass is measured, its SI unit is kilograms, but it is sometimes measured in grams respective to what we are measuring. So 1000 grams is equal to 1 kg, 1 gram is equal to 0.01 kg. Now moving forward, weight. Weight is a force. Weight is a gravitational force on an object with mass. So this is an object which has m mass, and weight is the force acting on it, the gravitational force acting on it, which is the weight. So weight is a force, so it is a vector quantity. It has magnitude plus direction. Mm, It has magnitude plus direction, and the SI unit for force is Newton. So SI unit for weight, which is also a force, is Newton. Weight is the effect of a gravitational field on a mass. Now I'll tell you what gravitational field is. Gravitational field is the extent till where the force of gravity can be what do you say, felt. So weight is defined as the force acting on an object due to the gravitational attraction. Planets have a strong gravitational field. Why? That is because they have a higher mass. They attract nearby masses with a strong gravitational forces, as the planets themselves have a lot of mass. So the if little bit of gravitational force acting on it is also acting on it, huge effects can be seen. Now, I'm sure you all would not easily understand the concept, but further we'll see a formula to calculate weight, and there you can understand the relation between mass and the force of gravity, which is G, that is acceleration due to gravity. Moving further, what effects of weight? Objects stay firm on the ground. Objects always fall towards the ground, and satellites are kept in the orbit. So I'll just take you all to the next slide and show you here some of the phenomena associated with gravitational attraction and the weight of the force. So here you all can see the falling object is always attracted towards downward region, and the people are they stay firm on the ground, and satellites orbit around to the earth in the same circular path. And this phenomena we'll all this is there is another type of force, which is the centripetal force, which is also responsible for it, along with the gravitational force. And for centripetal force, we'll go through that in the further topics. But for now, satellites, they are kept in the orbit due to none other than the weight, which is the acceleration due to which is the force of gravity. Now, formula for calculating weight: the weight of a body is equal to the product of its mass and the acceleration of free fall. So you can rearrange this equation with this formula triangle any which ways. So but here this is the main thing. So we multiply weight with mass of the object into the g, which is acceleration due to gravity, and on earth. But if you're on another planet, the acceleration due to gravity might change because of various factors which are not so important here. But always remember, so you see, if a body has a lot of mass, the weight of the body increases, as weight is directly proportional to mass. If the g acceleration due to gravity on earth, it is kept constant. It is g is just acceleration due to gravity, but if we are on earth, it's constant everywhere, which is 9.81 newtons per kg or meter per second square. So if it's constant, what happens is that higher the mass, higher the weight. If lower the mass, less the weight. So there's a direct correlation or a direct proportion. They are directly proportional together. That is weight and mass. Moving further, friends, what is the gravitational field strength? Gravitational field strength is defined as the force per unit mass acting on an object in a gravitational field. On Earth, it is 9.8 newtons per kg or 9.81. But remember, you have to learn this, memorize this thing. It is 9.8 Newton per kg on Earth. Gravitational field strength is also known as acceleration of free fall or acceleration due to gravity. So this gravitational field strength is nothing but this symbol G in the equation W is equals to mg. So on force per unit mass acting on an object in a gravitational field in a range where the effect of gravity can be felt. So gravitational field strength is also known as acceleration of free fall or acceleration due to gravity. In context, the units are meter per second square. Always remember this, or Newton per kg. The value of gravitational field strength varies from planet to planet depending on the mass and their radius. And these are the factors which actually influence G, which is the gravitational field strength. So here you all can see that various planets, higher the mass of the object, higher the gravitational field strength. Always remember, this is something which is quite important. Here you can see that Uranus is smaller than, no, it's bigger than Earth, but it is smaller as the distance from the sun is quite far. So there's one more thing. Along with the mass of an object, the distance is also important. The distance of the object from the Earth is also important for the planets in our solar system to have their uh, gravitational field strength. As you can see that the mass of Uranus is larger than Earth, but it is quite far away. That is the reason why it has 9 newtons per kg, and Earth has 9.8 newtons per kg. But as you can see, Sun has the largest mass, is the largest in size. That is the reason why the gravitational field strength of the Sun, or the attractivity, the attraction for the gravitational force of attraction of Sun is quite high compared to all other celestial bodies present in our solar system. Now, mass versus weight. An object mass always remains the same. However, it is the weight which differ depending on the strength of the gravitational field of different planets. So always remember mass. If you are in your room, if you are in a different city, if you are in a different country, if you are in on a different planet, if you're on a moon, anything, your mass, if it is 80 kgs, it will always remain 80 kgs. Why? Because the quantity of matter in an object cannot change. So for example, the gravitational field strength on the moon is 1.63 newtons per kg, meaning an object's weight will be about 6 times less than on Earth. Now here you can see that mass of the person is 70 kgs, and the gravitational field strength on Earth is 9.81 newtons per kg. So weight, which is mass into G, will give us 687 newtons. But now going, if you're on moon, so your mass is constant. Always remember, mass is something which is always constant wherever you go. So mass is constant, but acceleration due to gravity is different because the moon has a lot less mass, a smaller radius, and the distance from Earth, distance from the sun depends. But still, as it has less mass and the radius is smaller, so the acceleration due to gravity there is almost 6 times less than that of Earth. So the weight of the person on moon would be mass into acceleration due to gravity on moon. That is 1.63 newtons per kg. So the weight would become 70 into 1.63 newtons per kg, which would give us 114 newtons. So this is it about mass and weight. Let's move forward to see if there's anything left. This was an easy topic and I'm sure you all must have enjoyed it. Oh, and there's one more thing. Using a balance. So the weight of two objects can be compared using a balance. This here, friends, which I am annotating close to. is a spring balance, and this spring balance is used to give us the weight of the object. And because the gravitational field strength is constant everywhere on Earth, this allows us to measure the mass of an object. Now, let me tell you. Here you can see that box X has 3 newtons, right? 3 newtons of weight. Now, what would be the mass? So weight is 3 newtons. We know that weight is equals to mass into acceleration due to gravity. So mass is something which is not given here, but what we have is that we have the acceleration due to gravity, which is 9.8, that is constant all over. So mass of the object would be equal to 3 newtons divided by 9.8. So that would be the mass of the object, and it would be in kilograms. You can convert it into grams so that the values would be easy and not in a lot of decimal places. So here are different types of balances. The second one, which is spring balance, you must also remember that there's an experiment given in the books regarding the spring balance. In this topic or the further topic, we'll discuss it in the future. And for now, just remember and learn the concepts, learn the definitions properly, learn the equation properly, learn how do you rearrange the equation, and just try to apply logic in the equation. So if you apply logic, the questions easily become easy. So thank you, friends. I hope you enjoyed it. Bye bye and have a great day ahead. And please like, follow, and subscribe my channel. Thank you.